You will be learning refining or purification of metals in this video. We find there are a variety of methods employed for refining of the metals. The refining processes are chosen depending on the nature of the metal and the impurities. Suppose we have a metal which is highly volatile. Such a metal can be purified by the process called distillation. Volatile metals are purified by distillation. Here, the metals which are volatile will have very low melting point. Examples are zinc, cadmium, mercury, copernicium, etc. These metals are taken in a retort, and with the help of a condenser, we collect the vapors into a beaker where the impurities remain in the retort and the pure distillate is collected as the metal. The second type of refining process is known as liquation. The process is based on the difference in fusibility of metals and impurities. When the impurities are less fusible than the metal itself, the process of liquation is done. Here, the impure metal or the crude metal is kept on a sloping hearth. What do you understand by sloping hearth? Sloping hearth is a furnace which has a slope. All over that, we place the metal to be purified. And when heating is done, you find that the fusible metal melts faster and it is collected at the other end, whereas the infusible materials remain as gang in the other end. Metals like bismuth, tin, lead, and mercury can be purified by this method. Coming to the next method, which is known as vapor phase refining. In this method, the crude metal is treated with a suitable reagent at a moderate temperature to form a volatile compound, and the volatile compound is later decomposed at a higher temperature to give the pure metal. The process of vapor phase refining is usually done for nickel, zirconium, titanium, etc. If the metal to be purified is nickel, the process is known as Mons process. Here, the metal is treated with carbon monoxide at a temperature around 330 to 350 Kelvin to form tetracarbonyl nickel. This is a highly volatile complex. The tetracarbonyl nickel compound that is formed on heating further at a higher temperature around 450 to 470 Kelvin produces pure nickel releasing carbon monoxide. This carbon monoxide can again be used for the process. Coming to the next vapor phase refining, which is done in the case of zirconium and titanium. The process is known as Van Arkel process. In Van Arkel process, the metal that is to be purified is heated in an evacuated vessel with iodine at around 870 Kelvin. Here, zirconium on treatment with iodine at 870 Kelvin will form tetraiodo iodo complex of zirconium, which undergoes thermal decomposition at a very high temperature around 2075 Kelvin in the presence of tungsten filament to form pure zirconium releasing iodine. Same is the case with titanium, the impure metal, when it is treated with iodine at the same temperature around 870 Kelvin forms tetraiodo complex of titanium, which on heating at around 1700 Kelvin in the presence of tungsten filament forms pure titanium releasing iodine. Both these cases, you find that it results in a volatile complex which undergoes thermal decomposition to produce the pure metal. The next method of refining is known as zone refining, otherwise referred to as fractional distillation. This method is essentially used by semiconductors like silicon, germanium, gallium, etc. to get extra pure metals. In this method, we follow the principle that impurities are more soluble in the melt compared to that in the solid state of the metal. Here, we take a circular heater through which the impure metal in the form of rod is passed through. The circular heater is heated and this is kept in an inert atmosphere. When the rod passes by, the moment it reaches the vicinity of the circular heater, it starts melting. And when it is coming out of that, you find that it crystallizes to form the pure metal. You find that impurities are sent back to the next zone where it is in the molten state. So the crystallized metal will contain only the pure metal atoms, whereas the impurities will be sent behind in the next zone. That is why it is known as zone refining. So as you find that the metal moves forward through the circular heater, the impurities get deposited at the rear end, and this process is repeated several times to get the impurities at the end. The last method of refining of metals is done by chromatographic methods. This is the most efficient method of separation, purification, and testing the purity of elements and the compounds. This was first used by Sweat in 1906. As seen from the diagram, you find that we have a long column in which we are packing an adsorbent material like silica or alumina. This forms the stationary phase, and the mixture to be separated is mixed with a suitable solvent and is eluted from the top. We find that there is a selective distribution of the various components of the mixture between the two phases, that is the stationary phase and the moving phase. The mixture and the solvent moves through the adsorbent. You find that the components of the mixture get adsorbed at different speeds. Those which are less strongly adsorbed move faster, and it gets adsorbed at the latter part of the column, whereas the one which is strongly adsorbed get adsorbed towards the first part. and so we get different colored bands at different regions, from which we can understand that the mixture contains more than one metals. Consequently, the original layers of the various components separate into a number of individual layers called bands. Each band is called a chromatogram. These bands are further separated by running more of the pure solvent down the column. This process is known as development. This method of separation is mainly used for those elements which are available in small amounts and the impurities are not very much different in chemical properties from the element to be purified.